Today we're going to talk about probability with two outcomes. So open your Inspire document, called that, and let's get going. In previous lessons, we found probability of a particular result on all trials. So we might have had a team winning, and their probability of winning is 3/4, and that means the probability of them losing is 1/4. They always add up to 1. Today we'll talk about what happens if we want to know about winning some and losing some, all in the same situation. Those situations are called Bernoulli experiments, named after that mathematician. In general, if the probability of success is p and the probability of failure is q, or 1 minus p, then we have a formula, NCR, p to the r, q to the n minus r, to find the number of successes in n trials. Looks terrifying. It's not. You don't even need to know the formula. You need to be able to follow the pattern. So here we go. Page 1-4. If the probability that a team will win a game is 3/4, what is the probability that the team will win exactly 4 out of 5 games? Win some, lose some. Well, if the probability that they win is 3/4, we're calling that our success. We want to know about them winning exactly 4 out of 5 times. So our probability of success then is 3/4, which means our probability of failure is 1/4. Those numbers always add up to 1. And that's our not rule. If I'm not successful, I'm 1 minus success, or failing, 1/4. I want to win exactly 4 out of 5 games. Doesn't matter what order I win them in, so it's a combination, 5 games winning 4. 5C4 times the probability of success, 3/4, to the number of successes I'm hoping for, 4, times the probability of failure, 1/4, to the number of failures. If I win 4 out of 5, I fail once out of 5 times. And then you go straight to your calculator and you type that in to your scratch pad. Hopefully you discovered that combinations are under the probability part of the menu, and you enter the top number first, separated by a comma with the lower number. And then again, the beauty of the Inspire is you can use your fractions templates and type that entire string in all at once so that you don't make little mistakes as you go along. It's probability, we want fraction answers, we do not care about reducing. Now your calculator will reduce sometimes, and that's okay, but don't force yourself to reduce. It just doesn't matter. So I enter everything into my Inspire, and I end up with 405 out of 1024. That is the probability that I will win exactly 4 out of 5 games if the probability of winning is 3/4. And that's the process, so we're just going to practice it a few more times. On page 1-5, a waiter knows from experience that 7 out of 10 people who dine will leave a tip. Last night he served 12 lone diners. What's the probability to the nearest thousandth that he will receive a tip from 9 of those 12 diners? So 7 out of 10 leave a tip. That's my probability of success. I'm talking about people who leave a tip. You need to understand that sometimes what we call success in statistics is not like a personal success. So you can't go by personal stuff, you just need to go by the problem given to you. I want a tip from any 9 out of 12 diners, so that's 12C9 times the probability of success to the 9th times the probability of failure. Well, if I'm successful 9 times out of 12, I'm fail 3 times out of 12. Again, once you've got your setup, you go to your calculator and type everything in. Again, the setup is more important than the answer. We look for the setup, for the work to be shown. You also need to write out your probability of success and your probability of failure. All of that work written is the work that gets you credit on a quiz or a test or a homework or whatever, even in college stats classes. So get used to this process now so that it'll seem really easy to you later on. And again, you just use your calculator to your advantage. If you know how to use your calculator, fast forward through this part and just check your answer with mine. That's huge. Copy it down, count your zeros, but then always go back and reread. This question asks for the answer to the nearest thousandth. So you go back to that problem and you approximate it, and you get 0.2397. Go back and reread again. It says to round to the nearest thousandth, which is 0.240. And again, we're just going to keep practicing this setup and process for 2 more problems. If you get it, pause and try some more on your own, and then check against mine. You can mute me, you can fast forward me, do whatever it takes for you to understand what's happening. So now I have the probability that a 2 shows on 3 different toss of a die. If I toss it 4 die, I get a 2 on 3 of them. So my probability of success is 1/6. My probability of failure is 5/6. I want to be successful 3 of 4 times, so 4C3. You always put your big number first with combinations. Times 1/6 to the third, 3 successes, times 5/6 to the first. If I'm successful 3 out of 4 times, then I'll fail 1 out of 4 times. Go to your calculator, punch everything in, check your answer against mine. Here we get 5 out of 324. So the probability of getting a 2 on 3 of 4 dice thrown is 5 out of 324. One last problem. A company that makes breakfast cereal puts a coupon for a free box of cereal in 3 out of every 20 boxes. What is the probability that Mrs. Sullivan will find 2 coupons in the next 5 boxes she buys? So getting a coupon is my success, not getting a coupon is my failure. I want to get 2 coupons in 5 boxes, that's 5C2, times the probability of success, 3/20, squared, because I need 2 successes out of 5, times the probability of failure, 17/20, to the third. If I'm successful 2 out of 5 times, I fail 3 out of 5 times. Again, take this to your calculator, type everything in, check your result against mine. And there you have the chance that she will get a coupon in 2 of the 5 boxes she buys. 44,217 over 320,000. Not a great chance. Careful of those cereal scams. And that's it. Have a great night.